for example, then we will discuss the questions based on heating effect. Say we are having two bulbs, right? One is 60 watt, 220 volt, means these are the ratings of the bulb, where they show what is the maximum power of the bulb and at what voltage we are using. And second bulb is 40 watt and 220 volt, and that way they are asking which number, first part, which one of the two has the greater resistance. Second, if we use the series combination or the parallel combination, then which of the two bulbs will glow brighter and why? So you know one thing, power is V square by R. So in that case, R is V square upon P, means resistance of the bulb is inversely proportional to its power. So we can say that way, your bulb B of 40 watt will have more resistance. Now second part, if we are having the parallel combination, so we say if we have to compare, so we apply the formula कि heat developed is V square upon R into T, and if heat developed is more in a given time, then the bulb will grow brighter. So in this case you can say it is inversely proportional to R. So we can say in parallel combination, the bulb having a smaller resistance will glow brighter. So in this case, the 60 watt bulb will glow brighter. And when we have the series combination, then formula is H is I square into R into T. So now it is directly proportional to resistance. So now the 40 watt bulb will glow brighter. Next question we are saying a torch bulb is given whose ratings are 5 volt and 500 milliampere. Then we have to calculate the resistance of the bulb and the energy consumed by the bulb when it is used for 2 hours. So you know voltage is given 5 volt. And current is 500 milliampere, to will convert it into ampere, that is 0.5 ampere. So power is V into I, that way we get 2.5 watt. Then resistance of the bulb is R is V upon I, that is 10 ohm on substituting the values. And last part energy, so that is power into time. So if there is no need to convert in this question. So that way we can say power is 2.5, time is 2, so 5 watt hour means give the proper unit. If you want, that is not necessary, then you can give the answer in kilowatt hour also or in joules also, but for that you have to do the conversions. So if you are giving the proper unit here, there is no need to converge in this values, means kilowatt hour or joules, because it is not specified in the question. And secondly, we are not calculating the electricity bill for which the conversion is needed. Next question is saying if we are having a number of electrical bulbs, we have to use them on 220 volt line. And the wattage of each bulb is, means the power of each bulb is 10 watt. So we have to calculate how many bulbs we have to use and in series or parallel watt combination if the maximum current that can flow through the combination is 5 ampere. Now you know the basic formula ki power is V square by R. So by using that formula, we can calculate the resistance of each bulb. That is V square upon P. So on solving, we get 4840 ohm. Now for the whole circuit, we know the maximum value of current and the voltage. So we can calculate the effective resistance of the circuit. That is V upon I. That is coming 44 ohm. Now you know for each bulb the resistance is 4840 and final resistance is 40 ohm, means this is lesser. So we say simply we have to use the parallel combination and say we are using n bulbs in parallel, then effective resistance will be 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Because n bulbs are there, so we get 1 upon R net is n upon R. And on solving, we get R net is R upon n. Substitute the values, so we get n is 110. Next question is saying if we are having an electrical iron of 1 kilowatt and we have to use it on 220 volt supply. So we have to calculate the rating of the fuse, means out of the choices given 1 ampere, 3 ampere, 4 ampere and 6 ampere, which one should be preferred and why. So do you know one thing, that we have to first calculate what is the current needed to operate the electric iron. So we know I is P upon V, so we get the value 4.54 ampere. Now we can't approximate the value and the next whole number is 5. If we see the values are 1 ampere, 3 ampere, 4 ampere and 6 ampere. Now it is more than 4, so we can't say it is approximately 4. So we need the current more than 4. So we have to use the 6 ampere fuse. And last question, we have to calculate the electricity bill for a family which is using a TV of 750 watt for 4 hours a day. Then 4 bulbs of 50 watt each, 10 hours a day. Then 5 fans of 80 watt each, 12 hours a day. And 1 refrigerator of 2 kilowatt for 20 hours a day. And it is given in the question that the month is of say 30 days, and the cost per unit of electricity is rupees 3 for first 200 units and rupees 5 for any additional unit above 200. So in this case, whenever a number of devices are given, then we say that instead of calculating separately, first calculate the total energy for the whole circuit. So we say that formula is P1 T1 plus P2 T2 plus P3 T3 and so on. So that way we just multiply it by the number of devices also. So we can say N1 P1 T1 plus N2 P2 T2 that way. So here because number of TV is 1. So that way we are saying P1 into T1 and convert the value of power in kilowatt. So that way we are having 750 into 4 upon 1000 plus 4 fans are there and 4 tube lights are there. That way we are using 4 into 50 upon 1000 into 10, and similarly 5 into 80 into 12 upon 1000, and last convert kilowatt to watt. So that way 2000 upon 1000 into 20 and multiply it by the number of days in the month in order to reduce the steps. So that way on solving, we get total units are 1494. The electricity bill it is given is rupees 3 for first 200. So that way we get for first 200 is rupees 3 and remaining 1294 it is by accordingly to rupees 5 per unit. So the total cost is coming 7070 rupees. So that's all for the day. And in the next video, you can, if you are having any query, you can ask. And in the next video, we'll start the next chapter.